You have already met Joe. He had been planning to take his wife on a trip to Paris after he retired from his job at the bank. He spent hours carefully researching that dream trip, thinking of the Eiffel Tower, the Arc de Triomphe, Champs-Élysées, and even perhaps a sunny side trip to Nice. But now, his world has shrunk. Diagnosed with cancer, he's forced to do a different, more terrifying type of research to understand his treatment options. He has been thinking about radiation therapy. To understand his choice, we have to look back. For centuries, cancer was a shadow, a whispered diagnosis that meant a slow, inevitable decline. It was mysterious, terrifying, and almost always fatal. The main weapon was surgery, a brutal, direct approach, cut out what you could see and hope for the best. But cancer is sneaky. It spreads through the body, sending out invisible seeds, what we now call metastases, that surgery can't always catch. Doctors were desperate for something more, a way to fight what they couldn't see. Imagine telling a family the tumor is back, somewhere unreachable. The helplessness for both doctor and patient was crushing. Rich or poor, cancer struck fear in everyone. People tried everything, strange diets, prayers, potions, but nothing truly worked. The medical world knew surgery alone could be like trimming weeds without pulling the roots. All too often, the problem would just grow back, often stronger than before. They needed a weapon that could reach deep into the body, kill the cancer at its source, and spare the healthy parts. Every new scientific discovery was scrutinized. Could this be the answer? The pressure was immense, lives were slipping away and hope was running out. The world was waiting for a miracle, a breakthrough that could change everything. The stage was set for a revolution, but no one knew where it would come from. The great minds of the era were pushing the boundaries of knowledge. The search for a new weapon was relentless. Science, medicine, and human hope were all on the line. The fight against cancer needed a new kind of hero, and soon the world would find one in the most unexpected place. In 1895, Wilhelm Röntgen discovered X-rays, creating the first image of his wife's hand. Soon after, Henri Becquerel discovered radioactivity, and the Curies isolated polonium and radium, elements with powerful, invisible energies. Could these rays do more than just take pictures? These discoveries gave medicine a new arsenal. The race to harness this new kind of light had begun. The battle against cancer would never be the same. But radiation was a mysterious new force, a double-edged sword. Its effects were obvious. Scientists handling radium developed terrible burns. This destructive power sparked a daring question. If it could damage healthy skin, could it be harnessed to destroy tumors? In 1896, a young medical student in Chicago named Emil Gruber took a leap of faith, trying X-rays on a woman with inoperable breast cancer, the very first documented attempt at radiation therapy. Early treatments were incredibly crude. With no established protocols, doctors simply guessed at doses, exposure times, and distances. Sometimes tumors shrank, but patients often suffered severe burns and debilitating side effects. The equipment itself was incredibly dangerous. Exposed tubes, sparking wires, and absolutely no protection for the patient or the operator. Unsurprisingly, many pioneers, including Marie Curie, paid with their health. Every patient was part of a risky experiment, but the potential was clear, a non-surgical way to attack tumors deep inside the body. Doctors like Gustafsson began refining the approach, using multiple weaker beams to focus on tumors and spare healthy tissue. The era of wild guesswork slowly gave way to science and strategy. Radiation therapy was becoming more than just a shot in the dark. It was a new frontier, dangerous but full of promise. The groundwork was laid for a revolution in cancer treatment. The invisible weapon was being aimed with increasing precision. The fight was just beginning. How does radiation fight cancer? It's all about DNA, the cell's instruction manual. Cancer cells have faulty instructions, multiplying out of control. Radiation acts like a saboteur, damaging the DNA inside these rogue cells. High-energy beams break DNA strands and create free radicals that attack from within. The goal damaged the cancer cell's DNA so badly it can't divide, triggering self-destruction. Healthy cells are hit too, but they're better at repairing themselves. That's why radiation is given in small, daily doses, fractionation, giving healthy cells time to recover while cancer cells accumulate damage. It's a war of attrition, exploiting cancer's weakness. The invisible scalpel cuts at the very blueprint of the disease. Modern radiation therapy is about precision, hitting the cancer, sparing as much healthy tissue as possible. The science is elegant. Use chaos against chaos. Every dose is a calculated strike. The aim is not just to destroy, but to heal. Radiation therapy turns the body's healing ability against the cancer. It's a battle fought at the microscopic level every day, and it's saving lives. Early radiation was like firing a blunderbuss, messy, imprecise, and risky. But technology evolved. By the 1950s, machines like the Cobalt-60 unit and linear accelerators, LINACs, arrived. LINACs could generate powerful controlled X-rays, treating deep tumors with less damage to healthy tissue. The real leap came with computers and CT scanners in the 1970s. For the first time, doctors could see tumors in 3D and plan treatments with pinpoint accuracy. Software allowed them to shape and modulate the radiation beam, matching the tumor's contours. Techniques like intensity-modulated radiation therapy, IMRT, delivered strong doses to tumors, sparing nearby organs. The blunderbuss became a sniper rifle. Modern radiation is targeted, precise, and adaptable. The technology transformed cancer care, turning a dangerous force into a life-saving tool. Every advance meant fewer side effects, better outcomes, and more hope. The rifle now has a computerized scope. The revolution continues, one innovation at a time. The future is precision.
Behind every scientific advance are real people. These are the stories of patients whose lives are fundamentally changed for the better. Take Mark, a builder with prostate cancer. Thanks to modern techniques, he gets highly focused radiation with minimal side effects. He can return to work quickly and keep his quality of life. Or Sarah, a young teacher with lymphoma. Her treatment is meticulously mapped in 3D, creating a plan that targets only the cancer, carefully sparing her heart and lungs. For some young patients, this means the risk of long-term side effects is dramatically reduced, safeguarding their future. Then there's David, whose advanced lung cancer spread to his bones, causing debilitating pain. A single dose of radiation relieves his pain, letting him walk and play with his grandkids. This is palliative care, using radiation to improve the quality of life, not just extend it. Each story is a victory for the scientists, the doctors, and most of all, the patients. Modern radiotherapy means more than survival. It means living well after cancer. It's about dignity, hope, and precious time. Every treatment plan is a chance for someone to have more, better days. The human face of technology is what matters most. These stories are the true measure of progress. Every improvement on a scan is a chance for a new beginning. The science is personal. The victories are real. The fight is for people, not just statistics. And that's what it's all about.
In 2025, radiation therapy is a cornerstone of cancer care used in about half of all cases. Sometimes it's the main treatment, curing cancers like those of the head, neck, cervix, and prostate. Other times it's combined with surgery or chemotherapy, shrinking tumors before surgery or mopping up stray cells after. Chemoradiation, the tag team approach, is standard for many tough cancers. Technology has leapt forward. VMAT delivers radiation in a continuous arc, cutting treatment times to minutes. Image-guided radiation therapy, IGRT, scans the patient before each session, adjusting for tiny changes and hitting the target every time. Stereotactic radiotherapy, nicknamed cyber knife or gamma knife, uses dozens of focused beams to treat small, hard-to-reach tumors with surgical precision. Even tumors in the brain or lung, once untreatable, can now be targeted safely. The sniper rifle analogy is real, one devastatingly accurate shot, no incision needed. Today's radiation therapy is faster, safer, and more effective than ever. The arsenal keeps growing, the future is already here, and it's saving lives every day. The future of radiotherapy is even brighter. Flash radiotherapy delivers a full course of treatment in a split second. Early research shows it kills cancer but spares healthy tissue. Scientists are exploring how radiation can boost immunotherapy, helping the body's own defenses attack cancer. Proton beam therapy is becoming more accessible, delivering energy precisely inside tumors with almost no exit dose, ideal for children and sensitive areas. New drugs called radiosensitizers may soon make only cancer cells more vulnerable to radiation. MRI-guided radiotherapy could let doctors watch tumors in real time, adapting the beam on the fly. The goal: smarter, faster, more personalized treatment for every patient. Science fiction is becoming reality. The next breakthroughs are already in the pipeline. The treatment is getting kinder, not just stronger. The future is about hope, not just survival. The invisible weapon is evolving. The best is yet to come. The story of radiation therapy is one of relentless human ingenuity. From a mysterious glow in a dark lab to AI-guided machines delivering sub-millimeter precision, it's a journey of courage and discovery. Pioneers risked everything, driven by the need for a better way to fight cancer. Today, radiation therapy is a quiet hero, turning a once fatal diagnosis into a treatable, often curable condition. For millions, it means more time, better time, and real hope. The fight isn't over. Cancer remains a formidable foe, but our weapons are sharper, faster, and smarter than ever. The pace of progress is accelerating. The journey that began with Röntgen and the Curies continues in labs and clinics worldwide. At its heart is a simple idea. Even in our darkest moments, there's always a ray of hope. Sometimes that hope is a literal beam of energy. Joe's cancer journey has just begun. The chapters of his story are yet to be written. But through his early research into the possibility of radiation therapy, he has learned a powerful lesson. The future is bright, and the fight goes on.